Okay, I do not have a great setup here. I definitely don't have the Wii Video or a touch screen or anything. So this is recorded on my cell phone at a wicked angle. So I'll do the best that I can. Maybe I'll even just try to hold it. Sorry if you get seasick with this. Okay, this is the chapter 12 review, page 5, I think it's 513, number 3. So it says the graph shows, let's just go up to it. The graph shows a normal curve for the random variable x with average and standard deviation that's unknown. It is known that probability that x is greater than or equal to 12 is 0.1. So that's that shaded part here. That's telling me the area over here is 0.1. So question A, part A, says the shaded region is that area. What is it? So the area is 0.1. That is that probability. It's also known that the probability that x is less than or equal to 8 is also 0.1. So that's going to be symmetric. If I have 0.1 for my area over here, then on the left, I would also have 0.1 area over here. I know it's on the left because we're less than a value, so that x coordinate that it would go with would be an 8 right here. So find the value of the average, explaining your method, explaining what you're doing. Okay, so again, sorry for the amazing film quality that we've got here. So here is my bell curve. If I know 0.1 is on this side at 12, and 0.1 of my area is on this side, trying to draw it symmetric, over here at 8, then the average, that mean, is also the median. That's in the middle here. So what is halfway between 8 and 10 that would split that difference? Because again, it's like if I were to, it's symmetric. If I fold this over, it would map back onto itself. So it'd have 10 in the middle. So find the value of the average, explaining my method. The average is equal to 10 because there is symmetry that's used. So it is in the middle of those two values. Part C, show that we get a standard deviation of 1.56. Any sort of show that question means that that has to be your end result. I can't assume it to be true. Okay, so what's an equation or a connection that I know between an average, standard deviation, and these x values, given that I have an area here of 0.1? Well, anytime I'm given an area, I can calculate z-score. So that z-score formula is in the formula booklet. It's the x-coordinate minus the average over standard deviation. And I'm solving for this, trying to show that I really do get 1.56 out. So I need to get the z-score from my calculator. So we'll have that over here. The x-coordinate, I would use, you can use either one of these regions. I'm going to use the one on the left here purely because I am going with my calculator I have at home, classic TI-83. So it only goes to the left, so it's a little bit easier for me to use that one. X-coordinate of 8 minus our average of 10 over the thing I am solving for. So to get that z-score in my calculator, oh my goodness, this thing is so old. I would go to the distribution menu. Because I'm looking for a z-score, that is the inverse norm option. Your calculator is going to look different. It's going to say area, mu, standard deviation. For your area, you're going to type in the area or the probability that you're using. For me, that's 0.1. It's probably 0.1 for you also. Then you would make sure that your average and standard deviation are set to the default. So 0 average, 1 for standard deviation. The way I'm doing it, it's my 0.1 area on the left because I'm using this 8 in my equation. So then if you've got that on your calculator, we'd make sure that left is highlighted. This thing is so old, it's going to give me z-score when I do that. So I have a z-score of negative 1.28 approximately. And from here, I'm then solving for our standard deviation. So I can cross multiply. Sorry, it keeps going in and out of focus. I can cross multiply here. So that's going to give me a negative 1.28 multiplied by sigma equal to 8 minus 10, or negative 2. And then from there, it is negative 2 divided by that value. Sorry, camera work, terrible. So I have negative 2 divided by the unrounded number here, and that's going to give me, whoa, old calculator, 1.56, which is what we were trying to show. Part D asks us to find the probability that x is less than or equal to 11. Okay, we now know the average of 10, the standard deviation of 1.56. Even if I couldn't come up with that, like they told me it was that, so I can use it in future parts. And we want everything less than 11. Find the probability. That means I'm using normal CDF. If I'm looking for a probability, and it's a normal distribution, that's norm CDF. If I'm given the probability, these 0.1s that are here, that's when I would use inverse norm. So I can do this on the calculator. Again, I've got an old classic here with me. So I go to my distribution menu and select norm CDF. My screen is going to look very different from yours. On yours, it's going to say lower, upper, I think standard deviation, or average and then standard deviation. So lower, upper, average, standard deviation. Okay, so lower boundary, I want everything less than 11. So pick something ridiculously to the left, even if it doesn't make sense for the problem. Negative 10,000, I don't know. Something that's more than 3 standard deviations away. Upper boundary, we're going up to 11, average of the numbers that I have there. So my old calculator, I think I type in the left boundary, comma, the right boundary, comma, average, comma, standard deviation. Let's hope that that's it. So I'm getting 0.739 for that probability. I hope that that is right, because I haven't entered it the old way in a minute. So about 73%. Okay, so this was 0.1%. This was this was 0.1, this was 0.1. So 0.739. If I'm at 11, like here, this is 50% plus a little more. It seems reasonable that this would be around 74%. So I think I'm okay.